Here's a follow-up video to the one I just did about calculating moments. Okay, and so we're going to build another structure here, just randomly connecting straight lines to show this concept. Okay, and let's label some points. Let's label point A and point B. Alright, so I'm only going to apply one force here to try to focus on a certain aspect of this problem. Let's put this force, but it's not operating in strictly the horizontal or vertical direction. It's actually operating at some angle theta. Okay, so let's define that angle to be 30 degrees from down from the horizontal. Okay, so with this picture in mind, let's calculate the moments at point A and point B. Okay, so let's also assume this is 100-pound force. And that the grid is showing feet. So the resulting torque would be in foot-pounds. Okay, so the idea here is that you really just simply need to resolve the force into its horizontal and vertical components, and then do the same thing that we did before. Okay, so I'm going to put this in green. All right, so if I take this force, I could resolve that into the downward y component and the horizontal component. Okay, so if it was 100-pound force and this is theta, then across from theta is the vertical force down. So this would be 100 sine of 30 degrees working down, and this would be, the horizontal force would be 100 cosine of 30 degrees working down. I'm sorry, working back to the left. Okay, so from there it's just a matter of applying these lines of action like we did before. So for point A, we notice the line of action that's perpendicular to the force goes this way, and so that is 1, 2, 3, 4. I'm sorry, let me start over. Too many points here. 1, 2, 3, 4, 5, 6, 7, 8, 9 grid points. Okay, and so that would be 9 times 100 times the sine of 30 degrees, because that's the vertical component. Okay, and then we ask ourselves, is this rotating clockwise or counterclockwise? Remember, our definition, or the way we are trying to consistently do this, is counterclockwise rotations get the positive sign. Okay, so if that's working down, that would push this into a clockwise direction, so we would need a minus sign here. Okay, so that's the first part of resolving that force that works at an angle and how it would generate a moment at point A. Okay, so we also need to do the horizontal part, okay, and so if we extend our line of action here, we can tell that that's 3 units up. Okay, so we need to add the moment due to this horizontal component of the 100-pound force. So that would be 3 times 100 times the cosine of 30 degrees, and we should also check to make sure that the rotation is correct. So if this was pushing horizontally, this would cause a counterclockwise rotation, and in fact we do need the plus sign. Okay, so you calculate that, and that's the answer in pound force, or sorry, foot-pounds. All right, let's do the same thing for the sum of moments at about point B. Okay, so it's the same kind of thing where you resolve the components into vertical and horizontal directions. All right, and so we look at this line of action for the vertical force. Okay, the distance to that is 3. Okay, so we would need 3 times 100 times sine of 30 degrees. Okay, because that's the resolved vertical force. Okay, and which way does that cause the rotation? That would cause the rotation to be clockwise, and so this would need a minus sign. Okay, so that takes care of the vertical component. The horizontal component, the line of action moves this way, and so we count up 1, 2, 3, 4, 5, 6, 7. All right, so 7 times 100 times cosine 30 degrees. Okay, and then which way is this causing the rotation? This would cause the rotation to be counterclockwise, so this would be a plus sign. Okay, and again, the distance was in feet and the force was in pounds, so this gives me a torque in foot-pounds. All right, so that's simple enough. I'm going to stop there, and I think that from here on we'll be able to quickly resolve how to calculate moments about any point.